Okay, let's go ahead and get started. This is the case study. Jack Henry & Associates automates application deployments through Crises with disaster recovery architecture and release automation. I hope you're in the right place, and I hope that you find this information productive and useful. So a couple of obligatory legal disclaimers here. From CA, the content provided in CA World presentation is intended for informational purposes only and does not inform any type of warranty. Information provided by a CA partner and CA customer has not been reviewed for accuracy by CA. And then our own Jack Henry disclaimer: dates contained in this presentation are provided as estimates only and can be changed at any time at the sole discretion of Jack Henry. This information may not be incorporated into any contract and should not be relied upon in the decision-making process. So, first of all, who am I? My name is Chris Farrar. I'm an advanced systems and network administrator for Jack Henry & Associates. My current role is I'm an automation subject matter expert for release automation. That means I work with the development and operations teams to engineer deployments for the release automation through the release automation application. Where it's appropriate. Where it's not appropriate, I act as a DevOps advisor, advisory capacity to design release processes. I got some previous experience before that in the Springfield, Missouri area. I worked for another major retailer doing design, deployment automation, and scripting. That's where I kind of started to cut my teeth on it. I was a part of a major Windows XP upgrade project that required a significant amount of automation to complete in the time frame that they'd wanted it done in. So I started doing it then and loved it, and I'm still doing it now. So what was the importance of a disaster recovery architecture to Jack Henry? Our primary business driver was business continuity. We want to make sure that our services, our applications are available to our customers no matter what. Whether primary sites fail, secondary sites fail, thinking worst case scenario. Jack Henry is prepared for the worst case scenario in a major disaster event. So if there's issues with the secondary site, we can actually spin up brand new servers and deploy code to those servers on the fly. We need to be prepared to stay in a disaster recovery scenario for an extended period of time. So if we're running on servers off of the secondary site, we want to be able to deploy updates there indefinitely and run off of that as long as we need to. And since the release automation deploys code quickly and efficiently, it's critical to that disaster recovery strategy. So to back up just a little bit, how do we use release automation? The organization within Jack Henry that I am with is called Card Processing Solutions, and I'm on the release team. Like I said, we're responsible for coordinating release activities for dozens of applications underneath our organization. These applications span Windows, Linux, and mainframe platforms, so there's a big variance in the way that they're deployed fundamentally. We look to release automation as a way to standardize and centralize those deployments across all those platforms. Currently, it is a work in progress for us. Of those dozens of applications, we deploy 4 of them through release automation. We do some light SharePoint dashboarding where we update SharePoint sites with information that management and other organizations within the company can view, see what the current releases are and current environments of applications. We do some limited reporting we use limited reporting capabilities at this time. Release automation has a plethora of reporting information available contained within it. We just kind of scratch the surface, and that's something we'd really like to leverage going forward. We look to expand on that significantly in the near future. Currently, we deploy binaries with it very well. It's very good at moving files and artifacts from one place to another place, transcending kind of firewalls, transcending domain issues. It's very good at transferring stuff. We do notifications on the fly, scripted notifications in real time as applications deploy when they complete deployment. And we have some custom duration reporting that was requested by management where we can actually break down the processes and see how long each process took, what the downtime was for each component of an application. We also deploy database scripts reliably. We have a rollback, so at any point we have a light touch rollback. If something goes sideways in the middle of a deployment, we can, with the click of a button, revert everything back to the way it was before we started, hopefully get the application back up within minutes. We have a custom approval database that we use where we send approval notifications to our managers From the email, they can click a link and then update the approval database accordingly to approve or deny a release to any environment. Our flagship application that we use for this release is a web portal for ATM monitoring. What it does, it allows financial institution customers to monitor ATM profitability, monitor ATM status, cash supplies in ATMs. They can push updates to ATMs, pretty much all things ATM. Since using release automation for this application, we've seen a significant reduction in our deployment times. It's less than 5 minutes from beginning to finish, which was usually about a 30 to 45-minute process manually. We've completely eliminated human error. Since it's all automated, it's a light touch. There's only a single-click interaction relied upon with the operator, where they select which build they want to deploy. As I stated before, we have scripted notifications taking place in real time as the application deploys, when it completes, and a summary afterwards. And then all that data is archived and stored so that we can use it for audit purposes later on. We can see exactly who deployed an application, what version they deployed it to, what environments, and retain those records indefinitely. So the issue that we had with release automation is that out of the box, it comes with a high availability architecture, HA. What this means is that there's 2 management servers here and here and a load balancer between them. This is great for high volume deployment shops because it allows release automation to be able to keep up with thousands of deployments without experiencing any slowdown or any delays while it's processing that data. However, there's still 2 single points of failure here and here. The artifact repository and the database server. If either one of those components go down for any reason, then you can't use release automation. So that doesn't fit into a true disaster recovery architecture. We had some very specific goals going into it that we knew we needed to accomplish. As a standard requirement, Jack Henry requires that all applications have a disaster recovery counterpart to fail over to. So you have to have a primary site and a secondary site. In addition, we knew that out of RA, we needed RA to function in the event of a total site failure. We needed to have access to the artifacts, and we needed to have access to the agents or the servers that we wanted to deploy those artifacts to. So we identified the single points of failure, but we needed to come up with a solution to get around them. Essentially, we doubled down on them. Now I'm going to slow down on this slide because this is really the meat of why everybody's here. This is how this entire thing works. To start out, I want to outline our primary environment. We have a management server, an execution server, a database server, and an external repository. Underneath this primary data center, we have agents, or the servers that we run to. And then we have a secondary site with an execution server and all the DR servers for our individual applications. There's a third leg that's our development leg. And we have a development execution server that talks to development servers. Now, these span physical data centers, but they're generally constrained to the development domain. We access from our local workstation. We have a VPN connection into the domain where all this is located. And that's how we interact with RA, because it's not a publicly facing, publicly accessible site. It's behind all of our firewalls. So, like I said, essentially we just doubled down on what we had. We mirrored our existing environment. We created a second management server for disaster recovery, a second execution server, a second database server, and a second repository. In addition, we updated on the agents, on all of our individual agents. There's a file, NIMI config file. And what this file does, it's a configuration file that controls how the servers interact with each other, how they communicate with each other. We have our NIMI config updated for all of our primary data center agents so that it looks for the execution server for the primary data center first, and in the event that it can't find it, it'll actually go look and find the secondary execution server. In addition, we have all the agents in our secondary execution server configured the same way, so they'll seek out the primary execution server if they can't find it. This creates a full mesh backup so that any of the agents can access either one of the execution servers at any point. So if we lose an execution server to a leg, we can still reach the agents in that data center. In addition, we have our secondary database that we replicate back and forth, and then a secondary repository that we replicate back and forth. Our secondary management server we have in an active standby configuration. So we have our primary management server active at all times, and then we have our agent service running on our secondary management server, and that allows us to monitor it, make sure that it's up, and notify us if there's any issues. But in the event of a failover, we turn on that Nolio server service, which then activates that second management server. So,
in the first slide, you showed a load balancer, and that wasn't in the second slide.
I'm going to circle back to questions right at the end, but yeah, we do. So we have the SQL and the repository servers. So we need to replicate the information between those so that they're available at either side. For the repository, just to back up, we do have the Nexus. We utilize the Nexus artifact repository, which is what ships out of box with RA. RA is compatible with many different artifact repositories, and a lot of them do have internal methods for replicating the data back to other server or other data centers. Unfortunately, Nexus does not have an officially supported one. They have a recommended way in which they recommend rsync, which is an open source file replication tool, to replicate certain file directories. They do, we use, since we're primarily a Microsoft shop, we use DFSR. I've included in the slide notes a little bit about DFSR if anybody's not familiar with it. It's a feature that's configurable within Microsoft Server. But the bottom line is that the repository is just a flat file system. So if you can replicate the file system from one place to another, it'll be available when you need it. So we set up DFSR, and we copied the conf folder, configuration folder, the logs, the plugin repository, and the storage here. Now there's a couple of files that are specific to the server. Those are actually updated by the Nolio server service on the local management server, whichever one's running it. Those are the indexer file, and then under the timeline directory, there's an additional index file. So we set up exclusion rules for those. So every 15 minutes, we're replicating all the files that we need to be replicating, specifically the storage folder, because that's where your artifacts essentially live, and excluding the indexer and index files. For the SQL replication, we set up log shipping. Now there's, depending on which kind of database you have, obviously again, there's countless ways to replicate databases. We went with the most basic one for a version 1.0 just to get a working model. It does add a couple of manual steps to our failover process. For one, we have to disable log shipping job on both sides. We also had a script because when you configure a log shipping job, it puts the secondary database into a read-only state. And we have a script that we run that pulls that out of the read-only state, makes it available for use. Again, we went with this method just for the low administrative overhead for it, and just due to the infrequency of testing. We only test our DR a couple times a year, and it's not a big deal for us to go in and set up the log shipping, configure it each way. But that is something that I'll do at a later slide. We are looking for future improvements on. So we got all our communications opened. We got our mirror environment configured and stood up. What happened when we flipped the switch? Release automation worked. We could access the dashboard. We could access reporting, log into it. Everything was functional. Unfortunately, we couldn't actually deploy a production application. In our first round of testing, we revealed an inherent kind of a flaw with our design is that we have a single point of failure in our design. The dev execution server couldn't connect to the management server, and we rely on that for some of the approval functionality that we built into it. Now, in that first slide, we didn't include any sort of secondary point of failure for the dev leg because we figured that in a disaster recovery event, we wouldn't necessarily need access to the development servers. We would only need to worry about the prod servers. But obviously, that's not the case. We also found we have a persistent server type that we use across all our applications called utility. and we assign the management server to that server type. We use it to stage files, we use it to send emails as a utility. Since that's statically set within the application, that needs to be changed and switched over to whatever the secondary management server is. We had a few of the usual permission and access issues. Those are kind of one-time fixes, specifically with DBAs being able to access some of the SQL tables and things of that nature. But we got those fixed. So we took those results, we took our lessons learned, we opened up a line of communication from the secondary management server to that dev leg. And that's very important because of all the reasons that I just stated. We're also working on, for a future state, having a second replication of that so that we don't have a single point of failure to our development environment. So we included the utility server changeover in our process as well. We go in and we change over that server type for any of the servers that we need whenever we're deploying out of the DR site. So we took the second round of testing. We were finally able to deploy. As of right now, we can deploy production applications completely with our primary data center shut down. Since we were able to deploy a full deployment, we actually found just a couple of other small things, kind of some of that dynamic duration reporting that I had referenced earlier. We run queries against the primary database, and since that's set statically within the application, we have to change that over to point it at the secondary SQL server as well. But that's a simple 2-minute fix, and it's written into our process now, so we know to expect it. We also had some process adjustments surrounding backup times and just procedural things of that nature. So future state, some stuff that we're looking to do to improve is we would like a scripted solution for changing the utility server type. That's just a matter of coming up with a REST call or a SQL query. We don't want to have to do that manually to switch those over. We're going to be looking at more automated SQL replication so that we don't have to configure log shipping each time that we trip our DR. If we went with like an always-on configuration, then we could let SQL handle, point the redirection of servers if one becomes unavailable. Also, we're looking at integrating our management servers into more of a high availability configuration. We currently run them out of an active standby right now, but it wouldn't be terribly difficult for us just to take the configuration files on that second management server and point them at the primary database and repository servers, at which point we could access either management server and deploy from it without the need to have to switch over configuration files and such as part of our process. So what does that actually mean for the Flagship application, for the web portal application? Well, we're now able to deploy the application in the event of a total site failure. So if we have a complete total site failure and our secondary site goes down, we can actually spin up servers from scratch and use release automation to deploy code to those servers to get it back up and running within minutes. Also, if the DR environment, if the primary site was destroyed, we could run out of our disaster recovery environment indefinitely and even spin up a completely new DR environment and so on and so forth. So we're definitely prepared for the worst case scenario there. So, Jim, I think you had said you had a question about the load balancer.
In the first slide, when you showed the load topography,
Mm-hmm.
there was a load balancer. And then
Are you talking about the original? So you're saying in the first slide there was a load balancer displayed, but in the second one there wasn't?
yeah.
So
You had 2 management servers and a load balancer.
mm-hmm.
And then you went to the next one.
Yeah.
You had 1 management server.
Well, there's still 2 management servers, but there's no load balancer. And the difference is because when it was released out of box, what was given is the high availability architecture. And like I said, that's really more for high volume deployments. It's to make sure that the management server doesn't choke on the deployments, yeah. And that's where the load balancer comes in. Since we aren't really a high volume shop yet, we don't really rely on the load balancer to distribute between the 2 management servers. But by putting our secondary management server from our DR configuration into that high availability configuration, we could add a load balancer and then very easily just change over to that to where either management server would be available. And if the secondary management server wasn't available, then the load balancer would just point at whichever one was the primary site. Yes?
Yeah, quick question. Why did you choose not to use a SQL Server cluster for your DR data?
Honestly, it was just for version 1.0. Like I said, it was lower administrative overhead. It was easier to configure the log shipping to get it up and going. And then we knew that, future state, we were going to want to do that. Primarily, it was just for our DBAs for administrative overhead, at this point, because.
So at a later point, you would want to replace the replicated database into a SQL Server cluster that did it automatically.
Exactly, yeah. And that was for zero touch.
And if you went to a load balance situation, you would be active.
Mm-hmm.
And be able to run, you don't even have to switch things.
Yeah, we went with this design to get something up and running and working. Now we can identify where our manual processes are and then try to automate those processes. And that's exactly the way that we handle the deployments and release automation. We have our manual steps that we do, identify those and target them, and then figure out how to automate them. So yes, precisely, that is where we're going with the future state of it.
Pick my brain.
Mm-hmm. So, good question. Yes?
So at this point with the replication or the log shipping that you do every 15 minutes, at most you'll lose, if you drop the site immediately, you're just going to lose at most 15 minutes.
Sure. There is a potential there. If you had just uploaded an artifact and, there is the potential that you may have to re-upload that artifact. But, the chances of that are very minimal. And in the event, the worst thing is that, especially the way that our deployments run, they check for the artifact anyway. So our deployment would just check, see that the artifact wasn't there, and re-register it with the repository. So, good questions. Anybody else? Okay. I'll be around after the session as well. If there's anybody that wants to exchange emails or talk, very specific details, if you're looking to do something like this, I'd be happy to exchange info for you. We did provide a few other recommended sessions if you found this interesting. GM Financial transforms app deployments with CA release automation and gold deployment standards. Jewelers Mutual Insurance streamlines complex app deployment with CA release automation. And GM Financial builds a sustainable, holistic, continuous delivery practice. Also, a few must-see demos on the floor. Modernize app delivery, manage multiple app releases, orchestrate your release, and deliver test data faster. Oh, yeah, certainly. Mm-hmm. So, thank you.